So I just remind you those properties of determinant once, then I will be solving few sums so that you can start on your own from your textbooks or from any book. Property 1, just quick revision, value of determinant remains unchanged if its rows and columns are interchanged. Transpose of a determinant has the same value as that of the original determinant. Property 2, if any two rows of a determinant are interchanged, the sign of the determinant will change. Value will remain the same, only the sign will change. If any two rows or columns of a determinant are identical, the value of the determinant equal to 0. We will be using all these. Next one, if you multiply a determinant by a scalar, then only one row or one column multiplied by the same. Fifth one, sum or all the elements of a row or column determinant are expressed as sum of two. It is summation of two determinants. If in a row the elements are expressed as sum of two or more elements, the whole determinant can be expressed as sum of two determinants. And if to each element of a row or column of a determinant, you multiply by a constant and add to the elements of another row, then value of the determinant will remain the same. Similar is the case for columns, and we can perform it for many rows and many columns, isn't it? Let us start with this sum where we are going to apply all the properties we have learned. Okay? For this one, we subtract this one from this one and this one, because it can be done. Elements of one row or column can be added to another row or another column. So here delta going to be equal to what? 91, 94, 97. This you subtract. It is 1, 1, 1, and here it is 2, 2, 2. So do you think two columns are identical? No. One is scalar multiple of the other. In that case also value will be 0. We can modify the property. We said that two rows are identical or two columns are identical, value is 0. Now I am saying that if elements of a row or column is a constant multiple of the other, then also value equal to 0. If you don't want to accept this, take two common outside. Then 91, 94, 97, 1, 1, 1, 1, 1, 1. Now these two are identical, value will be 0. Clear? Understand? So every time don't forget to write steps for a descriptive paper. What you have done there? C2 dashed, C2 minus C1, C3 dashed, C3 minus C1. Clear? Now, then we have taking 2 as common from third column. Okay. Let us go for the second problem. Look at the board. You have to prove that this thing equal to this thing. B plus C, Q plus R, Y plus, these are all common sums given most of the books. You'll find this kind of thing. I show you step by step by using those properties how to get LHS to RHS. So start this manner. What we'll do here, adding second and third row to the first row. R1 dash equal to R1 plus R2 plus R3. Let us do it. So this will be twice A plus B plus C, P plus Q plus R, x plus y plus z, r plus p, z plus x. Alright, those properties only I am using. Elements of two rows added to the elements of another row. It is allowed. Now what you will do? You take these two outside. It is a plus b plus c, p plus q plus r, and then c plus a, r plus p, p plus q, x plus y. You understand? Operation you never forget to write. That taking 2 as common from the first row. Alright? Now what I will do there? I will be subtracting this one from this and this. Writing the operation here. That is R2 dash is R2 minus R1. This you can do repeated number of times for the sake of the sum. So you will get a plus b plus c, x plus y plus z, and subtracting this from here, minus b minus q minus y, and this one minus c minus r minus z. Clear? Understand? But some we are not able to prove yet. See, they asked you to prove this thing. So at least I can try to make one element in terms of one element. I don't want to express it as sum of two determinants. It is huge. So better you go for property. What I do here? R1 dash is R1 plus R2 plus R3. Just apply it. 2 into A P X minus B minus Q minus Y. So you have used R1 dash is R1 plus R2 plus R3. Clear? Done? Have I got it? Not yet. We have to get APX BQI. So what I'll do there, I'll be just taking the common minus 1 from second row and minus 1 from third row. 2 minus 1 APX CRZ. Clear? Okay. So we got the right hand side. You check now. We got this thing. We got same thing. You can check it once. Have we got? Go for the next problem. This one. Show that this thing equal to 0. Previous one okay? You have understood? Good. Now prove this thing equal to 0. Show that this determinant has value equal to 0. How to get it? We just do R1 dash equal to R1 plus R2 plus R3. So delta going to be 0, 0, 0. Understood? A minus B. This two unchanged. You don't make change simultaneously because you are operating with this. You will say that I will operate there also. Not possible. Never do that mistake. So I have just used, I got 3 zeros in a row. Value of the determinant should be equal to 0. Isn't it? Not a difficult sum. Go for next one. Evaluate this one. Very interesting sum. Very interesting. You cannot expand. I am telling you, do all these things by using properties. You have to use properties, nothing else. This determinant is known as skew symmetric determinant, and order of the determinant is 3. Remember, if it is a skew symmetric determinant of order 3 or 5 or 7, I mean odd, value must be 0 always. I am showing you how to get it. So to prove this, we assume this manner. Let delta equal to 0a minus b minus a 0 minus c. Assume this. Now changing rows into columns. What do you know about this? If you take transpose, value will remain the same. So or delta equal to 0 minus ab a0c, isn't it? Just changing rows into columns. Check. Value will remain the same. We have claimed. Now what you have to do? You take minus 1 common from first row. Taking minus 1 common from first, second and third row. Taking minus 1 common from first, second and third row. So it will be 0 a minus b minus a 0 minus c. What do you observe? What have I got there? Check. I got same delta back here, isn't it? So delta equal to minus delta. This implies, therefore delta equal to 0. Clear? Understood? So this determinant has value equal to 0. You try next one. Show that this thing is also equal to 0. We will be realizing that property, fifth property probably, where you can express a determinant as sum of two determinants. Isn't it? Here elements are added. Other two rows remain the same. Symmetry is there. So you start this manner. Let delta equal to ABC b plus 2y. This you write A, B, C. I am expressing this one as sum of two determinants. X, Y, Z plus A, B, C 2x and this is X, Y, Z. Clear? Do you find anything over there? No, if we don't take two common even from the first determinant, two rows are identical. Its value will be 0. Second one you take two common, or don't you just say that it is a scalar multiple of third row, so value will be 0. A, B, C, X, Y, Z. The value again it is, these two rows are similar, value going to be equal to 0. Clear? Understood? Let us go for next one. Prove that. I hope this you can complete before I do. You all try it, I will be waiting. Try this first. X plus 2a, you see the right hand side and try your level best to get. See the right hand side and try to get. I give you the clue. You just add all three elements. I mean elements of second and third row with the element of second row. Okay? Just do it. Yes, you just elements of second and third row add to the first row, or in case of columns, it will work both the way. Yes. Yes. Second and third with the first. How it can be? Second and third with the second? It can be, but it's of no use. Just use R1 dash equal to R1 plus R2. Just do it. Have you got? This is very easy. Delta equal to what? By adding. Oh, R1 dash equal to R1 plus R2 plus R3. Sorry. So this will be X plus 2A. X plus 2A. And this thing is AXA. AAX. Take X plus 2A out. 1, 1, 1. Now there is an advantage of getting 3 1s in a row or in a column. This one you can subtract from here and here. So write C2 dash, C2 minus C1, C3 minus C1. Just apply it. This is going to be X plus 2A, 1AA, 0, x minus a 0, 0, 0. Now you expand. X plus 2a, 1 into this thing, because rest are 0. There will be, understood, done, clear. Let's go for next one. Next one is bit challenging. Next one is bit challenging. A square plus 1 ab ac, ab b square plus 1 bc, AC, BC and C square plus 1 equal to this thing. So some technique you have to apply which will give you the right hand side quickly. But keeping AB, AC or BC is not very convenient one. So to get this one, what I will suggest you multiply the first row by A, second by B and third by C. See the fun? You just multiplying first, second and third row by A, B and C. Can you multiply without a reason? If you multiply, then you have to keep it outside, isn't it? So this is a square plus 1. Clear? AB square. This is a square into B, please. This is b into b square plus 1 and this one is okay. Why have I done this? Because row wise I have multiplied. Now I will be taking common column wise. Multiplying first, second and third row by ABC. That's why I kept it outside. Now I will be taking ABC common from first, second and third row. Clear? So if you do it, third row no, it is column. So you keep A from here, then what do you get? A square plus 1, B square, C square, B from here. What do you get? C from here. Isn't it? So done. It's going to be 1 plus A square B square plus 1 clear? Done? Have I got the answer? You have to get 1 plus A square plus B square plus C square. Have I got it? No, I haven't got it yet. But I can get. I add second and third row elements to the first row. Just do it. Use this operation. R1 dash equal to R1 plus R2 plus R3. Just do it and check whether you have got or not. Check. Just do this operation. Done. Just use this property R1 dashed R1 plus R2 plus R3. It's coming easily, isn't it? Once you understand properties, then it will be very interesting to apply determinant sums. But this is just starting. B square, so many things to explore in determinants. C square plus 1. Now take 1 plus A square plus B square plus C square plus 1 as common. Isn't it? Now I am not going to do B square C square 1 B square plus 1 C square. We have already used in solving sums 1, isn't it? Now subtract this from this and this. Okay? Just subtract first column from second and third. And then expand. Clear? Just expand. In next step only you are getting the answer. Okay? Clear? The value is 1 plus A square plus B square plus C square. Clear? Clear? Let us go for the next one. Show that this thing equal to 4A square B square C square. Today's class you learn the manipulation only. Kramer's rule you will do another session. Okay? How to evaluate this? Similar procedure. Let's see. If we add second and third row and subtract from first row, then you are not getting all zeros, but it will be simplified. So use this operation first. R1 minus R2 plus R3. Just do it. B square plus C square. B square plus C square, if you add and subtract, it will be 0. It will be minus 2B square. Isn't it? Done? I will use this up. Now what can I do? I can take minus B common from there. Just take minus 2 common, not minus B, minus 2 common from first row. So this is 0, C square, B square. And whenever you get the scope, you expand. But don't expand now. Can be simplified further. What way? R2 dash is R2 minus R1. So minus 2, 0. And there it will be B square, A square, 0. C square, 0, A square. Use this property and now expand. Now expand. Expansion will be easier. We got so many zeros. Isn't it? Just expand and check whether RH is coming or not. Minus 2, 0 into A4 minus 0, minus C square into b square into 0 minus a square c square. Check once. So this is going to be minus 2 into clear? It has become 4 square b square c square. Okay? That is the right hand side. We have expanded now. Have the right to expand. If you are a student from different board, remember the basic rule is you apply the property twice when you are answering board paper and then expand directly. In CBSE also this was the rule, but now it is excluded. So those who are going for board exam, they will just ensure that property used twice and then expand directly. We have used property twice, so I have the right to expand, isn't it? And in any entrance exam, including your CUET, JEE Main, there is no liability that I have to use property. In the beginning only, if I expand, it's fine. But then it may never terminate. Some will not terminate at all, and you will get wrong answer. So avoid thinking that I'll expand it and get it. No. Properties are invented because of this reason. Clear? Go for next sum. Another very good sum. Let's see how many of you can do it. Minus BC, B square plus BC, C square plus BC. I just give you the clue. You multiply first row by A, multiply first row by A, second row by B, and third row by C. Clear? And then take ABC common from first, second and third column. Proceed. Do it before I do it here. Multiply first row by A. Second row by B. Clear? Multiplying first row by A, second row by B and third row by C. Then taking ABC common from first, second and third column. Take ABC common from first, second and third column. Okay? We have multiplied, but you did not divide. You are wrong then. So keep it there. Now take A common from here. What will you get? It is minus BC, AB plus BC and AC plus BC. Clear? I have taken A common from first column. So what is remaining over there? Minus BC. Here AB plus BC. Here AC plus BC. Similarly, you take B common from here. Alright, BH common, CH common, isn't it? Now it's very easy to get. See the right hand side, it is AB plus BC plus CA whole cube. At least one you will get quickly. You just add second and third row to the first row. Use this operation. Use R1 dash equal to R1 plus R2 plus R3. Just do it and tell me what is happening. You have taken A, B, C common, all get cancelled. Now use this operation. What you are getting there? A, B, B, C, C, A. A, B, B, C, C, A. Here also, rest get cancelled. So what is remaining over there? Just write. And from first row, you take AB plus BC plus CA common. Okay. So this will be 1, 1, 1. Now I am just writing one more operation, apply it and you get the answer. Just use this after this. C2 dashed, C3 dashed is, I'll wait for your calculation. Do finish it by using this property. C2 dash C2 minus C1, C3 dash C3 minus C1. Do it, it's coming then. Done, you got? It's coming, no? AB plus BC plus CA whole cube. This kind of manipulation is there in determinant. It's a huge expression, suddenly it is reduced by the application of property. So AB plus BC plus CA, subtract this from this and this. 1, 0, 0. This will be what? AB plus BC and this thing 0. This one AC plus BC and then 0, and this one is minus of AB, BC, AC. Expand in terms of any row, any column. What is remaining over there? Check. Take AB and then expand. This, if you expand, it will be what? 1 into this small determinant. 0. Alright? So AB, BC, CA. Minus minus plus, it will be AB plus BC plus CA whole square. So you got that thing cube. This only you are supposed to prove, isn't it? AB plus BC plus CA whole cube. How to get this kind of problem? How to solve this kind of problems? Y plus Z whole square, XY, ZX. And I think this is related to this kind. Okay, similar problems. So once I solve one of them, the rest you can get easily. Should I solve this one? Solve this one first. Most of the students find this one difficult. See how to get it. I always look at the right hand side. It is 1 plus a square plus b square. I have to get that. So how can I get it quickly? That I'll think. If I have a plus b square over there or there, then it will be convenient for me. So the operation I suggest you use R1 dash equal to R1 plus B R3 and R2 dash equal to R2 plus what? No, R2 minus A R3. Clear? So left hand side is what? If you add 2b square here, it is becoming this one 0. Use this operation I have written here. Clear? See what is happening there. So this is going to be, and here what do you get? Minus 2b plus b is minus b. Take minus b common. Isn't it? So from first row this term can be taken common. Let's see what happened in the second row. This is also a into 1 plus clear? From first row 1 plus a square plus b square. Second row 1 plus a square plus b square. Take it common. Taking this thing common from first and second row. 1, 0 minus b, 0, 1, a, If you want to proceed, you do. But as I told you, if you find it easier for you to expand now, do that. No problem. But think whether can we simplify it or not. Is it possible to simplify? Just check once. No, not very convenient one. So better you expand. It will be 1 into so 1 plus a square whole square, and what do you get? 1 plus a square minus b square plus 2b square. Finished. I got 1 plus a square plus b square to the power 3 by 2. Clear? To the power 3. Answer is this. Hope you have understood how to apply properties in solving determinants. Isn't it? Now, you need to do some problems from here. Okay? Next session I am coming with Cramer's rule, solving equations. Matrix also. Matrix you need to learn first.